welcome to Locana Lounge. I'm your host, Jen Campbell. I focus on innovation and product growth here at Locana. And I'm joined today by Amit Sinha, who's leading up our AI innovation and use case exploration here at Locana and has a lot of really exciting developments with using machine learning on some of our customer challenges that we're seeing today. So thank you for joining, Amit. I'm pretty jazzed about all the conversations we've been having and some of the great traction we've been seeing when we're applying machine learning and AI to those customer challenges. And I'm really eager to dive into that space with you today. And in particular, one of the programs, the pilot programs that we've been supporting recently has some pretty exciting efficiency gains. And we're leveraging ML to expedite a conflation process for that customer. So, and one of the statistics that I got super excited as we've been moving through that pilot, 6 times faster conflation process than traditional methods have shown. So I'm really eager to kind of learn more about that, but also just in general, how you're exploring some of those other use cases and diving into customer problems a little bit deeper and thinking about not just applying AI on like the business analytics side, though we know that that's a critical piece, and of course weaving in geospatial and GIS to those questions, but also thinking about using ML, and again, that pilot program being an example, to do data enrichment kind of earlier in that modernization program, because we know that for AI, especially when you're talking about things like conversational AI, you have to have quality data, reliable data, in order for that output, those analytics to be effective, to be correct, and to really have the richness of information, right? So, this idea of applying AI and ML to data enrichment to prepare for what's coming with future technology is an area that I think is pretty exciting. So if you wouldn't mind just kind of framing up where you're hoping to go with the conversation today, and thinking about that data enrichment and use case exploration that you're seeing in the market right now.
Yeah, thank you, Jen. Super excited to be here today. So the AI field is exploding. It is transformational, and it's going to change a lot of sectors in the economy. Though some of the major tech trends today, they are making use and leveraging AI to improve efficiency. And as you said, in one of the pilot programs that we conducted, we saw massive efficiency gains, up to 6x. So what that means is what you could do in 30 days now can be done in 5 days, and what you could do in 10 years can be done in 1.5 years. And that allows actually our decision makers and planners to map out a plan to fix their data and enrich their data using a variety of sources in such a way that the data, now there is more information from data available. In the data investment is leveraged because we typically spend a lot of money collecting data from multiple sources, multiple vendors. They all need to be aligned. They need to line up. So, and they should be they should be presented in a way to the client that we can actually make use of that in business analytics. So it's super exciting time to be here. AI is one of the transformational forces in the industry today, and our industry, utilities, engineering, and construction, is going to be impacted hugely from AI. And I'm very happy and excited that we are in the forefront, and we are like in a situation where we can make impact and bring a lot of efficiency and productivity gains to our consumers.
That's awesome, Amit. Thank you for that kind of summary. And I know that our whole team is just so excited to have you as part of this team. And I learn so much from you on a daily basis. So I'm really excited to kind of talk through this a little bit more. But just for a quick background, my name, again, Jen Campbell. I spent about a decade working at Esri, so I kind of know that GIS space pretty deeply, and then about a decade working in ERP implementations. So joining Locana was really fun to bring those worlds together and kind of interconnect GIS with business systems in a deeper way. but it was, to your point, such an exciting time to join Locana because we're on the cusp of a huge wave of new technologies. But for me, it's more new ways of doing your day-to-day work, right? So this technology to me is the statistic I saw just really got me energized, and I think it might have been in one of the articles that our teams published, but it switched from 20% strategic and 80% tactical to 80% strategic and 20% tactical. That's the promise that this
Yeah.
technology can bring. It does the grunt work for us. And seeing this evolve in the GIS space and seeing how GIS interconnects with business systems through this technology to enable that shift in how people work is one of the most exciting points that I'm glad to be here. So, but Amit, please tell us a little bit more about your background, your
Yeah.
inspiration, and what drove you to join the Locana team.
Yeah, sure. So my background in terms of education, I got drawn to artificial intelligence and machine learning in the 90s when I joined my PhD program, and I specialized in optimization, simulation, and automatic differentiation. These are common techniques that are used in machine learning. They have become part of most of the modern libraries in machine learning, like PyTorch or TensorFlow. And so, what I used to do in a couple of months now to write code to do certain aspects of machine learning today can be done in 1 or 2 lines because they have been abstracted away. So it has the process is so
Amazing.
much more efficient, and also it reduces the entry barrier for people who want to get into the game. So for those users who are excited about machine learning and want to make use of it, there are very powerful libraries out there that are available today. So after I finished my education, I got into the industry and I worked with the satellite imageries, geospatial technology,
Mhm.
distributed computing, and lots of similar technologies. Like so, for instance, some of the technologies that actually were related more towards how do we actually make use of satellite imageries and aerial imageries to extract features so we can test or we can verify if the data set that we have actually aligns with them. That was one of the first computer vision exercises that I was engaged in. And when Locana got in touch with me, I was very excited because very forward-looking company has a lot of innovation going on here, and this was a perfect platform that I was looking for to get started and drive this initiative of AI to apply into different sectors, like whether it's gas utility or electrical utility or water utility or engineering and construction. These are all great areas and they have their challenges in the AI, which we'll talk about. Yeah, but extremely important areas because they constitute a very big portion of our national GDP, and whatever impacts we make in productivity gains here, it actually translates into gains for a lot of users, a huge swath of population in the country. Like everyone needs
Mhm.
utilities, everyone needs
Yeah,
water,
totally.
electricity, right? So if we make a difference here, those gains are going to change the lives of those people there. It's going to make their processes more efficient as well.
Yeah, yeah, absolutely. I mean, I think that's a fascinating point. It really does touch everybody's lives. I mean, we like to think about the folks, speaking of utilities, right? Those who are in that industry really trying to solve problems and tackle all kinds of business headaches that come up. But it, it, ultimately, they are serving the end customer and delivering that resource to the customer. So that customer is going to be impacted too. That every single person is going to taste the results of this technology in one way or another. Um, but Amit, as you are kind of looking at some of the technology trends and the business trends of today, what do you see as the biggest challenge? The one that kind of bubbles up as, central, like this one we have to tackle.
Right. For AI is data hungry. It's data is the oil that runs AI. And if and data also runs business analytics, business intelligence. But in AI in particular, we need to get data in a certain form that can be used here. And in the utilities, engineering, and construction sectors, they face a unique challenge in applying AI due to scarcity of data. For
Yeah.
example, if you go to the internet and you search for gas valves or meters or regulators, you're not going to find much there. You will get some snippets, some images from manufacturers, but there is not much there out that can be really used for training a machine learning model to make predictions
Yeah.
or for
Yeah.
data enrichment, for instance, as you talked about earlier. So unlike some industries, these utilities they are heavily regulated. They prioritize security and privacy, and this often translates to restricted access. So it cuts both
Yeah.
ways.
That's
Yes,
right.
we are secure, but also the data is no longer available, and there are like we have to go through a special process to collect data. And in our case, we work with utilities, many of the forward-looking utilities in the nation. They are actually very open to the idea of like we coming down to their site, taking pictures and collecting data. That was one of the sources of us getting AI ready data. Similarly,
Mm-hmm.
we have issues with data being multimodal. Like for instance, a place can be represented by multiple modes. Like, for instance, an aerial imagery will show a place in a certain way. It's
Mm-hmm.
the top view of that place. And a street view imagery will show that the same place in a different view. Their resolutions are different. We require the aerial imageries to be free of occlusions, and the lighting should be uniform. Um, and it's very important that these two different sources of data that tell the story about the same place they are aligned.
Yeah. Yeah.
If
That's a really good point, Amit.
yeah, because if they're not aligned, there is not much use to it. We are forced to use only one view of the data and discard the other view of data. It's like a symphony, an orchestra, like playing a piece where you have one of the instruments missing and you know how the impact comes out. It's not complete. So that's the issue with with data quality. And therefore, uh, it's very important that we pay a lot of attention to our processes in such a way that when we are operating, we are constantly collecting data, so it's ready for AI.
Yeah.
Right? We have the visual. One of the things that we have, we are um, we are trying to convince our clients and have actually taken it as one of the missions at Locana and TRC is that all our processes should practice AI first approach where
Mm-hmm.
AI is the
Mm-hmm.
first layer in the stack and all other layers are built on top of that. So it
Yeah.
means that whatever we do, we monitor it, we collect data, and we store that data in such a way that not only that data is ready for AI, but it's readily accessible to
Mm-hmm.
users
Mm-hmm.
across the board,
Yeah.
who they want to make use of. So I think those two are some of the biggest challenges: lack of AI ready data, data not being aligned from multiple modes, and once we address those challenges, I think we are going to be in a pretty good spot. Like, for instance, inaccurate training data
Mm-hmm.
can
Mm-hmm.
introduce bias, it can
Mm-hmm.
produce
Yeah.
misleading
Right.
outputs. And in the business world, high quality data is a prerequisite to deriving business intelligence. It's a core
That's
component of a
right.
strategic decision making that
Exactly.
companies use to make to gain a competitive advantage. So bad data can waste resources, can it can make wrong decisions. I cannot emphasize enough how important the quality of data is, and that's one of the major goals here, that we
Yes.
make use of AI to improve the quality of data so it can be used effectively and correctly in our analytics to improve our daily lives.
Yeah. And I liked that concept of thinking about AI and ML for data enrichment. I think that term captures it well because it covers completing your data set, correcting your data set, interweaving multiple data sets so that you can get that multifaceted view that you're talking about, that more complete view of the situation that is out in the field. And we know that a number of customers that have a lot of valuable assets out in the field, that, to your point earlier, it is a huge gap, and it is, it's amplified by, how long these utilities have been in business, the age of some of that infrastructure, the ways that records were kept in the past. All of that amplifies this gap and this pain. So thinking about using AI and ML for that data enrichment, thinking of it as an umbrella term there, I think that's a really great point, that is really one of the biggest pain points and gaps that we can leverage this technology to solve. So I'd like to play on that a little bit more, though, and hear from your opinion, what are some incidents you've seen? I mean, we know that like some of our near and dear customers, the incidents can be kind of quite intense from bad data, but I'm wondering, for more a general audience to kind of think of a practical, maybe day-to-day situation that they may experience because of bad data quality, just to kind of bridge that gap a little bit.
Right. We experience the impact of data quality on a daily basis. We may not realize it. One of the examples that I like is there are so many online retailers selling stuff on
Yes.
their e-commerce sites. We place an order, we purchase it, and we enter our address for delivery. There's a time window there when it's going to be delivered. We're expecting it to be delivered, and then we get a notification, hey, the driver is in your area
Mm-hmm, mm-hmm.
and is still doing circles, not able to find you because the location that we entered was not correct on their map. So now we have two problems here. The delivery driver is on our area, is getting frustrated, is not able to make delivery, so probably made a delivery to a wrong location
Mm,
or did not deliver at all.
yeah, yeah.
So so now we have a dissatisfied customer who's ready to churn, probably, and
Mm-hmm.
we have a net revenue loss to the company.
Yeah. Yeah,
And
I think those are, and tying it to the results, both for the customer experience, but also to the business, I think is an important point, because it affects the full spectrum. Everyone who's engaging with that process will have an impact. And ultimately, customer satisfaction does impact business performance in the future, business revenue, return customers, that kind of thing. So it is truly an end-to-end, again, multifaceted problem that touches every single process. So I think that's a great example. But thinking about, us in the GIS space, how do these things translate to spatial challenges, and how important really is spatial intelligence and accuracy to drive those business insights that you've been touching on?
right, so Jen, like continuing on the previous example, and you laid it out very elegantly. GIS has two components, right? GIS data is spatial, it has geometry and it has attribution. So the geometry tells us where that data is located, and the attribution tells us what it is about that particular data. So,
Mm-hmm.
um,
Okay.
and it's a critical piece of information for deriving business intelligence and decision making. Because if we have to fix a valve or a regulator at a gas regulator station, we better know it exactly where it's located,
Yeah, that's right. Exactly.
right? If the technician who's out on the field crew does not know the location exactly, not just that they're on the premises now, but even within the premises, because it's a large premise many a time,
Yeah, that's
and
right.
they can spend quite a bit of time looking at the drawings where it is showing the valve is located, and it's quite a walk to look at their drawings from there to go to actual location on the field where it is situated, so they can make repairs there and maintain the
Mm-hmm.
asset.
Mm-hmm. Yeah,
And
I think that's a great point to make, because from some stories that I've heard, kind of listening to customer pain points, in there are cases where the data's spatial locations are so far off that it's showing on a completely different street.
Mhm, mhm,
And then if you're talking about more condensed assets, like some of the facilities and stations that need maintenance, like the precision there is critical to be able to find that. And it's a direct impact on efficiency and, of course, safety.
Yeah,
Knowing that you're working on the right asset is critical for ultimately that end customer feeling safe and getting the service they need.
yeah, absolute.
So,
Safety is one of the top concerns of utilities, engineering, and construction companies. We want our employees to be safe. If there's a leak on a gas pipeline, we want that pipeline to be located quickly so the field crew can be dispatched, they can fix
exactly.
it. Now, and because a safe work environment is one of the major goals of our company as well. It's a
Yes.
requirement across the industry because it builds trust, and trust
Yes.
is
Yes.
critical to success of any business. So
Exactly.
these are critical pieces of information that drive business decisions and impact us on a daily basis. So yeah, so if you look at it, all these elements of data enrichment, data
Hmm.
availability for AI, they play very well into the GIS space as well. The added thing is that we have a location to deal with, which needs to be accurate, and that introduces additional challenges.
Yeah, yeah, that's a great point, Amit. Thank you. So, and these are, I think, nice to lead into the next question about seeing so much, sometimes I'll say imperfect data
Yeah.
with our customer spaces and just these challenges, especially for asset intensive companies. So, and we touched again, like earlier in the conversation about this data enrichment and leveraging AI, not just for that, the analytics side, but really earlier in the modernization project around making the situation better. So as you've been, diving deeper into use cases with customers and driving some of these pilot programs, what are some specific ways that you are thinking about leveraging AI to improve the situation?
Right. So imperfect data needs to be fixed. We all agree on that. Right. So location and attribution that's typically associated with a GIS data element or entity, um, we need to fix it at an affordable cost. So the time to value period is a lot shorter than we have seen with traditional methods, and that's one of the driving forces that we have here. For instance, for attribute values for a geographic feature, we can use AI to clean the data, detect anomalies there, and validate the existing data. We can find patterns there. AI algorithm can be trained to identify and correct common data errors like missing values, inconsistencies, and
Hmm.
outliers. And this can automate a significant portion of the data cleaning process, freeing up human experts to do more complex
Hmm.
tasks. For instance,
Hmm.
data validation that we've talked about, supervised machine learning models can be trained on high quality data to learn about patterns and relationships.
Okay.
For location, we can use accurate sensor data coming from aerial or satellite imageries for feature extraction. AI
Yep.
can be used to automate the process of extracting features like buildings, roads, vegetations, and
Hmm.
from satellite imageries. This can significantly reduce the time and resources needed for spatial data analysis in GIS. And as we use AI to improve data, it is important to keep an eye on the explainability and bias. As with any AI system, ensuring explainability and mitigating potential biases in AI models used for data cleaning is essential.
Right.
Right?
Yeah.
Because if our AI data is biased already, it does not have enough representation from both genders or multiple gender.
Right, right.
Right.
Yeah, that makes a lot of sense because
Right. Then
you're
it's
really
going
making
to
sure that yeah, no, sorry, go ahead.
Right. So it's going to learn representations of only that data that's available in the training corpus. It's not going to learn everything. And we want data to be well
Right.
represented and representative of the society per se. So every parts of the society are represented very well, so everyone can benefit from it.
Yeah, that's really fascinating a bit. And again, just love how much I learned from you every time we talk, but thinking about making sure that as you're training the model that you aren't getting those biases. So watching for that and making sure that the data, the learning training data is high quality and diverse so that you are getting a well-rounded result. That's a really fascinating point.
Yeah.
But we talked a little bit earlier about this pilot program, right? A specific one where we saw 6 times
Mhm.
efficiency gain, time to value, which is a pretty exciting number. But like thinking about that program in particular, can you share some of the specific insights that you learned from that effort?
Yeah, absolutely, Jen. So this is a very forward-looking utility client that we have been working with for years, that supplies gas and electricity to millions of customers in the US. They're very active, and they are very receptive of the idea of using AI to improve their processes. They have internal processes as well. And so when we met with them, uh, it was a very exciting meeting where we were able to bounce off ideas to actually improve the processes as they exist today. Now, supplying energy to so many customers, it requires them to maintain a huge network of transmission and distribution lines. So, and they have actually a champion inside and in the company who obsesses about the accuracy of data, right?
That's
Because it
awesome.
directly affects the safety of the employees and customers and enables better decision making. So he understands that really well. So they identified an issue with data accuracy where they found that the location of transmission and distribution lines in the system of records did not align with accurate aerial imagery. And we
Mm,
had a conversation about it. Can we fix that? So met with them. So they already had a process in place to fix their data, and we met with them. We helped them identify those areas that needed to be conflated, meaning that those areas that needed more effort because the shift and the offset between data that exists in their database
mm-hmm,
versus
mm-hmm.
what you get to see in the base map and aerial imagery, which is the reference map,
Right.
it was large. So we helped them prioritize those areas using a data assessment methodology. And then we went on to make use of computer vision technology to train our
Okay.
models to actually extract those features and fix them in the databases automatically. And
That's
here,
amazing.
yeah, and here we actually were able to achieve an efficiency of 6 times based off the current methodology. And this was great because this is one of the occasions because where client actually was doing this already,
Yeah,
but
right.
actually they already has a process in place, they had a team in place, and they were fixing the data. And so we were
Mm,
able to measure that this is the amount of time it takes you to fix these many transmission lines and electric assets and these in this area. And if we apply AI to do the same, how much time it's gonna take? And we saw massive improvements. And I said earlier,
amazing.
what was there a decade-long plan? Now will be over in a couple of years with them. So
That yeah, that well, and that is the result of a 6 times improvement when you have that big of a project on your hands, right? You have that high of data volume that needs that correction, and you're able to identify ways to come to do use ML and have training data that can do that extraction for you, right? So when you
exactly.
apply 6 times faster to a 10-year period, now actually one of the coolest things I heard from one of our one of the folks involved there was they can see this done before they retire, and
Yeah,
that's a real gain, right? That's like,
it is.
especially, you mentioned the champion in the organization. For those who care deeply about this challenge and have been living and breathing this challenge for decades of their lives because
Yeah.
they're in this industry, I mean, this has just got to be so huge, like just unbelievable, like almost magic, right?
Yeah, exactly. I mean, they have this sense that I'm going to retire with a purpose, uh,
Yeah,
with
exactly.
a goal that I started with, that it has been accomplished. It's a massive sense of accomplishment for those people, those champions who care deeply about the quality of data, and they look at the impact of it and deal with it on a daily basis. And for us, it gave us a lot of satisfaction because we were effective in solving our client's problem, which is our goal as a company.
Yeah, that it's across the board, just such an amazing win and sense of accomplishment for, yeah, the champions, those who have been living and breathing this, but our team as well to help, them reach that goal. So you kind of mentioned conflation, right, as the specific technique that's had been used traditionally within this customer organization, and that we're leaning into with this particular application of machine learning. So can you tell us what exactly is conflation, and maybe touch on some of the other techniques that you've seen customers use to try and tackle this data imperfections in the past?
Right. Yeah, Jen, that's a great question. There are several companies that traditionally have used a methodology called conflation we talked about to fix location and attributes of geospatial features. So if you have to describe conflation, it's a process to get the best out of multiple data sources. We get the best
Mhm.
location, we get the best attribution, combine and put them together into a master data set. That's the conflated data set that we're making use of. And now we have multiple views of that particular entity from multiple data sources. All our data sources that we got from different vendors to spend money on that gets leveraged, and it helps us make much better decisions. So in this particular case, the client actually had an in-house process to fix the data alignment. The process required a lot of manual work. It was time consuming. It was tedious. We
Mhm.
met with them and looked at their process. One of the common questions in applying AI to solve a problem is how do we identify those components in the process where we can apply AI? How do we know that we can apply AI to improve this process? So what we
Yeah.
and the way we do this is same for any automation process. What we do is that we decompose the entire process into sequence of steps, and then we find out how much time each step takes. Okay, and then we ask question to ourselves, okay, this particular step takes a lot of time. For instance, if someone is manually
Okay.
viewing, looking at an aerial imagery to find an electric asset, it's a massive job. You have such a large area. How do you do that? It's very,
Yeah,
very
right.
difficult to do, right? So they had those kind of issues, like looking at it
Okay.
manually, trying to detect assets, and spending a lot of time. So we identified some of those pain points, some of those components in the process that where we apply AI, and if we were able to shave off and then make that time and make that process efficient, it will improve efficiency across the process. So we
Wow.
identified 3 or 4 steps in the process and
Okay.
augmented that with AI. And
Very
once we had
interesting.
augmented, we saw that the efficiency increased dramatically. And actually, this 6x is in the POC that you have seen, but
Hmm.
I think
Hmm.
we are very well positioned to increase all the way to an order of magnitude, maybe up to
Wow.
10x or even more in future. Because as we learn more
That's
about the
amazing.
system, there are more ways to optimize it and use by using AI and to make efficiency gains.
Yeah, that's fascinating, Amit. I appreciate walking through kind of how you approached it, right? And I also, back to the culture point you mentioned earlier within that organization, I think that's where it starts, is this culture of collaboration and being excited and motivated to open up that process to that level and do that next step analysis. And the fascinating part is, yeah, there's a bit of a time investment to go through that exercise and to think about each step and think about how you could apply ML to that. But it's it's a good return on time investment.
It is.
and
It
and
is
to your
indeed.
point, the deeper you go and the more steps you kind of think about and look for those patterns, y- y- to be able to potentially reach up to 10x is pretty, well, it's revolutionary to the market.
It is indeed revolutionary because for the first time, I think we have seen AI being applied to a process called conflation so effectively.
Yeah.
There have been efforts in the past, and I'm not aware of many uh, projects in the utility space where Utilities have conflation problem all the time. Many of the industries have, and we are happy to be a part of the process where we were able to help our client in a very effective way. And the way it
Mm-hmm.
works is
Mm-hmm.
that it has, like, you asked about what exactly is conflation. I touched about
Yeah.
it briefly,
Yeah.
and then I described the client process. So it is a multiple step process. It starts with data assessment. So to find out areas that need conflation, that need to be
Okay.
fixed, and we then establish a source of truth which we consider as a reference data. So it
Mm.
could be an aerial base map, for instance, an aerial imagery that we collect and say this is an accurate depiction of the area, and
Yeah.
then we look at those features that we have on our existing database and to see how they line up there. If there is an offset, like if there is an
Okay.
offset between parcels and the roads are off, the assets are a little off, we know that
Yeah.
there's a problem of data accuracy, and that needs to be addressed with conflation. So in this case also, when we completed our data assessment, we were able to identify those areas that needed to be prioritized, because the displacement between what existed on in the database and what we saw on the reference map, it was large in many of the areas. And then we made use of AI techniques like computer vision to predict locations of assets in the imagery, and that was used as a source of truth. And then we compared that with the source of truth and to come up with what we call displacement vectors. And these displacement vectors were then
Mm.
applied to existing data sets to fix their location. So now we have best of both worlds. We have the best location. We also have best attributions there.
That's amazing. And so that detail really, I think, helps me understand your earlier point too about bringing together multiple, like the best pieces of multiple data sources, and it precisely tells that story of the multiple facets of data. You're talking about one asset, but you need to look at it from different lenses. It has different attributes, it has different information, there's different, imagery available that talk about that one asset, that one piece of data. And so conflation allows you to bring all of those best pieces together in a systematic way and delivers on that complete story of that asset and that full data set. So thanks for describing that, because I think it perfectly outlines the how you get that multi perspective, which is
Exactly.
great. So
Yeah, so
the
computer vision, Jen, as we talked about,
yeah.
uh, it's a deep learning technique with neural networks. One of the fundamental units is like a neural network is it has neurons that we actually in. There's an input layer, there are hidden layers, there is an output layer, and one of the techniques that we made use of, and some of the made use of here um, is the ability to make use of some of the existing models and fine tuning them, and that actually supercharged it to this process, because we were able um, to train machine learning model for conflation in a much shorter period of time. Because initially, when we started, the amount of data that we had, it was not much
Yeah.
with the client. We always an issue with them, and they were wondering how we could do that. So we actually identified some of the models out there, went out there to fine tune them,
Mhm.
and then we were able to get results that looked excellent and improved productivity across the board.
Wow. Amazing. That's pretty cool, Amit. So then as customers are thinking about, leveraging techniques like this, maybe engaging with Locana, how would you say customers know that they need to conflate their data? And then even if they identify that problem, how do they get started?
Yeah, right. That's a great question. How do we know that we want to conflate our data? So I would suggest there is a simple way to do that. So we talked about an accurate reference data, right? We need to have that. Typically, many of the utilities, what they do is that they have an accurate cadastral map. We can either make use of those land-based maps, or we can make use of aerial imageries that are latest and greatest and accurate. There are
Okay.
many vendors that make them available. And what we could simply do is we can overlay our data on this accurate aerial map or the reference map and look at the locations of these geometric assets, right? Where these electric poles are, where the substations are located, where gas regulators are located, where meters are, and look at them if there is an offset that the
Hmm.
offset from their existing location as it shows on the map versus what it shows in our existing database. And if there's an offset, we go for a systematic study, as we just talked about. We do
Hmm.
fe- we do an assessment day of data to find out which areas need conflation. And for towards that end, what we have done is that we have developed a systematic process to assess data which is ready to go. So if someone wants to get started, they can talk to us, and we will be able to help them to identify areas pretty quickly because we have established that process. This is the first step. How do we
Nice.
know where we want to conflate our data? What we typically do is, in these cases, we randomly sample smaller areas to measure displacement. And then once we have measured these displacements, we construct a heat map of areas showing regions that need conflation.
Okay. Okay.
Okay, so this
Interesting.
enable, yeah, so this allows the businesses to have a visual representation of areas. Like
Hmm.
for instance, areas that need to be conflated could be shown in red, and those don't need to be conflated could be shown in green. So we know immediately
Yeah.
what the spread of those areas is. Now, you also about that, you know, how did they could get started,
Hmm.
right?
Hmm.
And and because we talked about that AI requires lots of data, and
Yes.
in our case, in this case particularly, the methodology that we have developed, if someone has an accurate aerial imagery, we can get started right away. And there are many agencies today that make these aerial imageries free of cost. There are satellite imageries, for instance,
Wow.
with very
Okay.
high resolution that are available. There are satellite imageries, for instance, from Landsat, Sentinel, and many that are freely available. So
That's
if we
amazing.
if we just wanted to get started, what you need is an intent and an understanding. Hey, we want to fix our data. So we help you identify those areas, and then we will help you find find some aerial imageries for that particular area, and we can just get started. We have machine learning models for asset detection ready to go. So that's not something you need to invest.
Right.
We
Right.
can make
Yep.
use of these machine learning models to make detections right away. And we also have an architecture that can consume their data if they have it.
Okay.
Like, there could
Yeah.
be many utilities, engineering, and construction companies that actually have it, and we can actually consume the data in our architecture for machine learning to create custom models for them.
Wow.
So
Wow. That's
this
pretty amazing.
Yeah, exactly. And so therefore, there's not much, fortunately, in this particular case to get started with. If you have the intent to fix data, we are here to help you.
Wow, that's very well described, Amit, because I mean, even just knowing that there's some freely available imagery data with at a high enough resolution to, do that assessment step, it just knowing that is really empowering. And the fact that you've gone through the process and research to see what sets are available for customers, because depending on their location, depending on their specific data needs, what they're trying to conflate, different freely available data sources may be the best applicable for their situation. So I think your expertise and what you built up with the team to just kind of have an inventory of that and be able to make those matches is very powerful. And then to your point about why reinvent the wheel? I mean, one of the things I always loved about working within in working with customers that do have that asset intensive nature to their business, so often there's this culture of sharing, yes, being exploratory, yes, being innovative, and then sharing what they've learned. So it's like, let's lean into that and be part of making these solutions together, um, and leverage what's been done, right? Because that's where you
Exactly.
get the best efficiency gains at the fastest rate, the quickest time to value.
Exactly. There's no need to reinvent the wheel.
Yeah, that well stated. So just thinking a little bit the forward now, right? Like I appreciate all the intel of this particular program and kind of how you've started to break it down a little bit and find those use cases for leveraging machine learning and AI. But what else do you see on the horizon for Locana and what we can bring to help customers solve this enrichment problem a little bit quicker?
Um, so the enrichment problem is one of the central problems that we are focused on solving today. There are other ways that we are also looking at to address it. So one of the ways that we want to do it is by constructing digital twins. So it's in the domain of robotics. And
Okay.
it's the idea of constructing a 3D model where we can locate the asset in a 3D space instead of a 2D space. So one of
Mm,
the traditional limitations with the construction of 3D models has been that it requires very specialized camera and specialized techniques to do that. What we are working on currently is a methodology where you can take your regular camera, even your iPhones, for instance, or your Android phones, and you can take pictures of a facility. And we have the technology to make use of those photos as such and convert them into a 3D model. So what that does is that it empowers people, right? Anyone can do a 3D model. That's besides the point. But those folks who are in the utility space and construction engineering, which is regularly other folks don't have access to, there is like a process to get even inside those premises. But they
mm-hmm.
so we can actually give them a regular camera. Many a times they have it, right? They have those cameras. They can make use of those cameras to take pictures inside, take videos inside, and we can take that feed and convert them into a 3D model. They're exciting technologies. Like structure from motion in the past has been superseded by many other techniques like nerves and Gaussian splatting that we want to make
Mm,
use of in future, and we are working on many of them. And to make so we know the 3D representation of an asset of a facility, because what that does is that it allows folks to do things from remote without coming to the office. And this way we can look at these 3D models and enrich that data even further. But because now we know the height, we know how many doors it has, how many windows it has, what kind of other facility we want to maintain that area, what kind of equipments we can take inside, what kind of access points they have, and all these things can be done remotely. So that's one of the exciting areas that we are working on. In addition to that, depth field estimation is another domain of robotics where
mm-hmm.
we want to make use of street view imageries and use computer vision to detect objects there. It could be anything for Department of Transportation. It could be traffic lights. For electrical utility, there could be electric poles. We can look at them, find out their heights, find out their location just by driving a vehicle around an area. We can plan a mission, and they could collect that data automatically and make the entire process super efficient. So we are very excited about the future of AI applications here because data enrichment is central. Whatever data we have, we want to have more information. So 3D modeling is one of the central pieces where we can make use of robotics and the associated technology to construct digital twins. And digital
Yeah.
twins can be used to simulate. For instance, whenever there is a new community coming up, we want to
Mm-hmm.
know how
Mm-hmm.
much additional gas we have to supply. And it's the
Yeah.
same regulator station that has to meet those demands. So it's very important that we
Right.
have the ability to first quantify what's that and the additional amount of energy is going to be supplied to those customers, and have these digital twins take it and simulate the process so we know that they can be handled safely and delivered to the customer reliably.
Yeah. Wow. That's so much there, Amit. I mean, I think that, let's keep talking. Let's have some more of these sessions because I just can't wait to see how you tactically unfold this with each pilot and customer opportunity that comes up, right? Because even what you were talking about with the conflation piece, being able to get that more detailed breakdown really helps make it real and helps make that feeling of this is doable, and the results really are going to benefit not only the organization but the customers that they serve. So really great stuff there with the digital twin, being able to do remote inspecting and getting, leveraging 3D virtual reality for design engineering, all of that. And then you mentioned robotics too. It's just so many possibilities, and it's going to be great to watch the team explore those. So any last
Absolutely.
thoughts before we wrap up here?
Yeah, so all of you who want to get started with AI, we are here to help. We have the skills and the expertise and experience, and we have proven track record. So we invite you all. So please contact us, and we are happy to work with you and we to improve efficiencies across the board and productivity and make your place much more safer. So we can all say that we all made use of AI to make our lives better.
Beautiful. Well stated, Amit. Thank you so much for joining me today and sharing all of your deep insights. This was exceptionally valuable. As always, I learned so much from you, and this is a really exciting time to be working in this space, watching our customers really grow and thrive and see those efficiencies that they've been dreaming about for decades. They're
Yeah.
here today, and they're within reach. So look forward to working with you, and yes, please reach out if you want to explore some of your processes. Um, Please do also follow up on the locana.co webpage. We have a ton of resources there. We've done many blogs talking about where we're going with AI and ML, some of these challenges that we've talked about here today. We also discussed there. And of course, reach out anytime on LinkedIn. We're always publishing new content there as well. So look forward to seeing you and keeping in touch. Thanks for your time.
Thank you.